Hi, today we're going to be doing lesson 4, session 3. We have finally arrived at multiplying with the standard algorithm. Up until now, we've learned how to multiply with an area model, and we've practiced multiplying with partial products. And now we're going to be doing multiplication with the standard algorithm. We'll be working in the workbook on pages 65 through 68 today. And so go ahead and take out your math workbook and turn to page 65. Now I'm already here. So I went ahead and answered our 3 questions for us. What is the problem about? It's finding the product. What are we trying to find out? What is 1,429 times 42? What's the important information? We are trying to find the product of these two numbers. So what I'd like for you to do right now is to multiply using your favorite method. You're welcome to use area model, partial products, or if you think you know how, you can go ahead and use the standard algorithm. So go ahead and pause the video, and then I'd like you to solve this math equation, which you can't see, using your favorite method. So again, you can use area model, partial products, or standard algorithm. Go ahead and pause it and then come back when you're finished. Okay, you probably got a really giant number, so we're going to see if that number is right. So to begin with, we're going to explore today different ways to understand how to find a product using the standard algorithm for multiplying multi-digit whole numbers. Here, we are multiplying using partial products. And so we are recording each partial product in a separate row. So we're multiplying this 2 in the ones place times 9 times 20 times 400 and times 1,000. And then we record each of them separately. Then we go over to the 4 in the tens place, and we multiply that 40 times 9 times 20 times 400 and times 1,000. And then we record all of those items separately on their own row. Then we can add all of the partial products for the ones and all of the partial products for the tens. And then we could add both of these partial products together to find the final product. Standard algorithm works similarly to partial products, except instead of recording each partial product on a separate row, we're going to record each product, all the partial products, on one row all together. An algorithm is a set of routine steps used to solve problems. With the standard algorithm for multiplication, you multiply by place value, regrouping and adding as you go. You record all the partial sums for each place value in a single row. So step 1, you multiply your ones, regroup as needed, record the partial products in one row. So first we go 2 times 9 is 18. We record the 8 in the ones place and then move the 1 up above the tens place. Then we multiply 2 times 2 and get 4, and then we add 1 more to that to get 5, which actually, since it's in the tens place, it means 50. Then we multiply 2 times 4 and get 8, which really means 800. And then 2 times 1 is 2, or it's in the 2,000 place. So our first partial product is 2,858. Now we need to multiply by tens. We'll regroup as needed. We'll record the partial product in the second row. So here, the most important thing that you need to remember is since we are working in the tens place, you need to go and record your placeholder 0 first, so that we can then multiply this 4 times 9, 4 times 2, 4 times 4, 4 times 1 to finish this out. But you need to put your placeholder 0 in. Once you put in your placeholder 0, then you're going to go. That means the same as multiplying 40 times 9, except we can just say what is 4 times 9, which is 36. We've already put our placeholder 0, so then we're going to put the 6 at the bottom and carry the 3 up above the tens. Then 4 times 2 is 8. We'll add the 3 carries, and that makes it 11. 1 down below, 1 carried up above the 4. 4 times 4 is 16, plus 1 is 17. We write the 7 down below, carry the 1, and then finally 4 times 1 is 4, plus 1 is 5. Then we have our second partial product. And then we could add those two together to find the final product. Now that we've looked at that, let's go ahead and connect all of it together. So what I'm going to have you do is, okay, so number 1 says, where do you see multiplying by 1s and 10s in the first modelet? So where do you see multiplying by 1s and 10s? The top in red is where you multiply by the 1s. 2 times 9, 2 times 20, 2 times 400, and 2 times 1,000 is what gives you all of these partial products. The bottom in blue is where you multiply by the 10s. 40 times 9, 40 times 20, 40 times 400, and then 40 times 1,000. And all of those together give you the 5,160. And so this is multiplying by your 1s. This is multiplying by your 10s. But now if we look at the second modelet down below, I'm going to put this on. There we go. If you look at the second modelet down below, how do the partial products 18, 40, 800, and 2,000 relate to the first step of the standard algorithm model? So if you look at the 18, 40, 800, and 2,000, if you take all of these and add them together, you get 2,858. Where else do we see that number? Interesting. When we look at the second modelet, how do the products, so now we're looking down below at the second modelet, how do the partial products 360, 800, 16,000, and 40,000 relate to the second step of the standard algorithm model? So if we look down here, we see all of these, when you add them all together, equal 5,160. And that is the same as the second row in the partial product. So instead of seeing it broken out in individual multiplication problems, we see all of the work done on a single row. Complete the multiplication in each modelet by adding the partial products. So I went ahead and just added together what is 57,160 plus 2,858. And the resulting product, or the addition sentence, and the final product is 60,018. Now, if we were to compare the partial product model and the standard algorithm model, we could see that both models multiply by 1s and then by 10s. The partial products model does each multiplication separately. So you see it's broken up here into separate rows. The standard algorithm does the partial products for the 1s and the 10s in one row each. So instead of having, up here we have 8 different rows that we add together. Here we do all the work in 2 rows and then add the 2 rows together. So now you've seen 3 different models. You've seen area model, partial products, and standard algorithm. I'd like for you to decide which models or strategies do you like best for understanding the standard algorithm for multiplying 2 multi-digit numbers. So which is your favorite strategy if you're going to be multiplying? Choose your favorite strategy and then tell me why. You can go ahead and pause your video until you finish that answer. All right, we're going to go ahead and turn to page 68. I would like to practice using the standard algorithm because so far we've only watched. So I'm going to do one with you, and then I'd like for you to do one by yourself, and then we'll do the last one. I'll do one by with you, and then I'll have you do the next two, and then I will check. So to do standard algorithm, this problem says the base of a storage bin has an area of 504 square inches. Its height is 18 inches. What is the volume of the storage bin? Estimate to check for reasonableness. Show your work. So let's go ahead and let's estimate first. So 504 is close to 500, so we're going to make that 500. 18 is really close to 20, so we're going to make that 20. So we're going to estimate what 500 times 20. So that is going to be 20 times 0 is 0, 20 times 0 is 0, 20 times 5 is 100. So we're going to be looking for an answer that's around 10,000. So let's check and see if we're right. So 504 times 18. So first, we're going to do the ones digit. I am not sure why this is having trouble focusing today. All right, so we're going to start with the 8. 8 times 4 is 32. We put the 2 down below, we carry the 3. 8 times 0 is 0, plus 3 is 3. 8 times 5 is 40. Next, we're going to remember to add our placeholder 0 because we're not multiplying 1 times 4, 1 times 0, and 1 times 5. We're multiplying 10 times 4, 10 times 0, and 10 times 5. So by putting this placeholder 0, that makes it so that we are showing that we're working in the tens place and not in the ones place. So then we're going to do 1 times 4, 4, 1 times 0, 0, 1 times 5, 5. Then we're going to add the two, we're going to add together the two partial products. 2 plus 0 is 2, 3 plus 4 is 7, 0 plus 0 is 0, 4 plus 5 is 9. So there are 9,072 cubic, because we're doing volume. I almost forgot cubic inches. And we knew our answer would be close to 10,000, and I think that that is pretty close to 10,000. So great job. So now I'd like for you to do number 8 and 9 on your own, remembering to first multiply by the ones digit by the top factors. Then don't forget your placeholder 0 because you're multiplying by a tens digit. Then multiply your tens digit times the top factors as well, and then add together to get your final product. So you're down here, you're going to do 1,075 times 25. And then down below, you're going to do 257 times 34. Go ahead and pause your video, do those two math problems, and then come back when you're done to see if you got them right. All right, we're going to go ahead and start. So if you have not finished these two problems, please pause it and finish them so that you can check to see if your answer matched mine. And then when you come back to check, if you made a mistake, you can always erase it and fix it. So first, we're going to multiply our ones digit, our ones place by the top factors. So 5 times 5 is 25. 5 times 7 is 35, plus 2 is 37. 5 times 0 is 5, plus 3 is 3. 5 times 1 is 5. Then we're going to multiply our, oh, I almost forgot. You need to then put your placeholder 0. That is going to be the number one thing that you might forget. So don't forget your placeholder 0 because we're really multiplying by 20, not by 2. But putting this 0 there makes it a little bit easier because the math isn't quite so high. So 2 times 5 is 10. I forgot sometimes it's helpful if you erase your carries so that you don't accidentally add them in the next time. So 2 times 5 is 10. 2 times 7 is 14 plus 1 is 15. 2 times 0 is 0 plus 1 is 1. And then 2 times 1 is 2. And then finally, you're going to add those all together. 5, 7, 8, 6, 2. Your solution is 26,875 markers. Did you get that answer as well? I hope so. All right, and then finally we're going to do 257 times 34. So first we will do the ones digit. 4 times 7 is 28. 4 times 5 is 20, plus 2 is 22. 4 times 2 is 8, plus 2 is 10. Then we're going to erase our carries so that we don't accidentally use those again. We're going to add our placeholder 0, and then we're going to work with the tens digit. Remember, this means 30, but we already put the 0 down here. So now we can just work with the 3. 3 times 7 is 21. 1, carry the 2. 3 times 5 is 15, plus 2 is 17. 3 times 2 is 6, plus 1 is 7. And then we can add those together. 8, 3, 7, 8. 8,738 is the product of 257 times 34. I hope that you felt pretty successful today. Tomorrow you will get to practice using the method that you find the best. So enjoy practicing your standard algorithm today on your independent classwork.